Hello chemistry fans, and welcome back to chemistry problem solving session for chemistry 1032 here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I will be guiding you through this problem today. The definitions for today are conjugate acid, conjugate base. All right, these are also pretty simple terms. They just look complicated, but they're actually very simple. A conjugate acid is formed from a base. What's that you say? It's formed from a base. That doesn't make any sense. And a conjugate base is formed from an acid. Whoa, this makes no sense at all. A conjugate acid is formed from a base, and a conjugate base is formed from an acid. That's absolutely true. Let's take a look at an example, just to kind of clarify this stuff, because it's hard to define these two terms, in my opinion, without an example. So let's just write hydrochloric acid plus water. Gives us hydronium, H3O plus is hydronium, plus Cl minus chloride. So over here we have HCl plus water, gives us hydronium plus chloride. That's the expression for an acid. This is hydrochloric acid, this is water, this is hydronium, this is chloride. Now, to define the conjugate acid and the conjugate base, oftentimes it's easier to think of things as pairs. We have an acid and a conjugate base. We have a base and a conjugate acid. It's easier to think of it that way. So let's identify the acid on the left. Okay? I like to play a little game called follow the element, or follow the atom. Over here we have a chlorine. So let's follow the atom. There's a Cl right there. So from left to right, the Cl has a hydrogen with it over here on the left, and on the right, the HCl has somehow lost the hydrogen, or a proton, if you will. Okay? So this HCl has lost a proton going from left to right. So this donated the proton somewhere. We haven't defined where yet, but this molecule, has donated a proton from left to right. So this must be an acid. Because if you follow the chlorine from left to right, the Cl, it goes from having a hydrogen attached to the Cl to not having a hydrogen attached to the Cl. So somewhere the proton has been donated. We haven't figured out where it's been donated to yet. We just know it's been donated. So now, let's follow the oxygen. So from left to right, the oxygen over here on the left had 2 hydrogens. Over here on the right, it now has 3 hydrogens. So somewhere between here and there, this water has picked up a proton, has gained a hydrogen, if you will. So this is a proton acceptor. So this is a base. This is my acid, this is my base. Now, that still doesn't define conjugate acid. Doesn't define conjugate base either. But think of them as pairs. An acid will always have a conjugate base. So over here, this is the conjugate base, because this chlorine over here is the chlorine over here. So these are paired. Conjugate base. The chloride is the conjugate base to the HCl. It basically, if you want to think of it, it is the base that forms after the proton is donated. Because now, in theory, this chlorine could accept the proton, in theory. This hydronium now, hydronium is the conjugate acid. How do I know that? Because it's connected to the base. It's paired with the water. The oxygen's here and the oxygen's here. So these are a pair. This has accepted a proton. So now over here, it's a conjugate acid. So let's draw this. Okay? So a conjugate acid, if you want to define it, you could say a conjugate acid is the acid or the molecule that forms after a base has accepted a proton. So again, is the acid that forms, or the molecule that forms, after a base has accepted a proton. Okay? So one more time. You start with an acid, you do an acid-base reaction, and you form a conjugate base. It's the base that forms, the conjugate base, is the base that forms after the acid has donated the proton. A conjugate acid is the molecule that forms after the base has received the proton. Conjugate acid is formed after the base receives the proton. And they always come in pairs. An acid always has a conjugate base. A base always has a conjugate acid. Now this is confusing. It's like, wow, there's just a lot of definitions being thrown around. It's not hard. You have to learn it. You have to try to study it a little bit and do a few examples and just try to remember it. It's very, very simple. Acid on the left, conjugate base on the right. Base on the left, conjugate acid on the right. Okay? But remember, they always go in pairs. Acid, conjugate base. Base, conjugate acid. Okay? So try that. Try to do a couple problems in your textbook if you need to. If you're having any difficulties understanding this, don't hesitate to contact one of the tutors here at the Academic Success Center or your professor during office hours. Don't let this sit. This is a very important concept, and it's not hard to understand. Just it takes a little bit of effort on your part, and we are more than happy to help you understand. Okay? Now with that, I wish you good luck and good chemistry.